So now we're ready to consider the first of our two options for grounding the loop end of our ground cord, and that's going to be with our wall outlet. Now before I get started here, I'm going to offer some words of caution. How I'm going to show you how to do this is how I've done it, and I've had my mat connected this way for quite some time and I haven't had any problems at all. However, realize that faults do occur in wiring, and no matter how cautious you are, there's no absolute guarantees, so you are proceeding at your own risk. If you're not comfortable working with mains wiring, if 120 volts alternating current is something you've never checked before, you probably should not continue. Also, I strongly recommend using only a quality multimeter to probe mains. When you probe mains with a multimeter, you are trusting your life to that meter. Use a quality meter for this procedure going forward only. Okay, so the first thing we're going to want to do is turn our meter on to volts alternating current, and there we are. And now we're going to want to use our multimeter to check the outlet. So first let's check between line that is power and neutral for both outlets. We should get 120 volts alternating current. Again, if you live in a different country, your voltages may be different. In fact, the outlets might be different altogether. So you'll definitely have to look up the specs for your country if you're outside the United States. There we go. So 118.8 volts alternating current, I'd say that's good. Now let's check the top outlet. And there we go, finally, 118.5 volts alternating current. So that's good. Now the next thing we're going to want to do is we're going to want to check from power to ground. Again, for both outlets. And again, we should get right about 120 volts alternating current. And there we are, 118.5 volts alternating current. Now we'll do the top outlet. And once again, 118.5 volts alternating current. I lost my connection there for a moment. Yeah, there we are, 118. Lost it again. 118.6 volts alternating current. That's good. Now what we're going to want to do is we're going to want to check from neutral to ground. And there should be an ever so slight voltage, but not really a significant one. And let's see if I can get my meter in there well enough. And there we are. I'm reading less than a volt. That's about 100 millivolts AC. So I'm going to say that's good. So there's a tiny little bit of volts alternating current there, but it's less than 1 volt alternating current. That's what it should be. Now let's check the top outlet. And my connection's not the greatest there, but eventually should get about the same here. It might be a little higher. There we are. So we're about, well, slightly higher here, but still well under 1 volt alternating current. So that's good. Now here, the last step is the most important. Since we're using the outlet as a ground, it's standard that the center screw has continuity with both ground terminals. In fact, that's why these grounds are made that way. The loop is meant to have the ground screw go through it. So we definitely want to check continuity, or I shouldn't say continuity, we want to check volts alternating current from here and here and here. All three of those should have essentially absolutely no voltage across them, because there should be a direct connection. So now I'm going to check between the ground of the top outlet and the center screw. And if we have some patience and we wait for our reading to come down and we make sure our connection is really on there well, we should get almost nothing here. And there we are, less than 3 millivolts AC, less than 2 millivolts AC. If we're patient for a little bit more, we should get under 1 millivolt AC. There we are, 0.9 millivolts AC. That's almost nothing. That's good. Now let's do the same check from the bottom outlet's ground to the ground screw. And there we go. Getting there, 2 millivolts AC. And 1 millivolt AC, less than 1 millivolt AC. I'd say that's good. And now let's check that the ground of the two outlets should do exactly the same thing. And there we are, we're getting darn close to 1 millivolt AC. 1.3, 1.2, 1.1, 1.0, and there we are, less than 1 millivolt AC. So I'm going to say at this point, we've done sufficient checks with our multimeter to say that this outlet is good. So there's one more thing that we're going to want to do, and that is we're going to want to use an outlet tester to check our outlet also. And how these outlet testers work, and you can buy these at any hardware store for $5–10, is that they have a series of codes on this label here that, depending on how these lights light up, it tells you the condition of the outlet. Now, these outlet testers are not an absolute test, but they're pretty darn accurate. If the outlet tester says the outlet's good, 99% likely it is. This particular outlet tester, if these two lights come on and this one does not, the outlet's good. So all the tests we just did previously would be a little bit much to do before every ESD session, but at a minimum we can quickly and easily take our outlet tester and check our outlet. So there's our two lights on, that's good. And there's our other two lights on, so that's good. So at this point I would say we've convinced ourselves that our outlet is good. So now it's time to remove the plate and put the ground screw through our loop. And there we go, there's our ground complete.